Well, isn't this a cheery little springtime video? Let's do some more simplifying rational expressions. Review the steps from last class. Okay, step one, remember, is factor both the numerator. Look, we're lazy. It's day two. Numerator and denominator completely. Step two is cancel like factors. Now remember, step 2 and 3 probably should be changed because step 3 is find and state the excluded values, but you really have to do that before you cancel, because otherwise if you cancel a whole lot, you can't see what you got. All right, let's go on to the first one. So the difference between this one and last one is they're not factored for, so we have to factor. Now I am not going to go over factoring. I'm not going to review factoring, but we're going to use this little flower petal here to put the types of factoring just so you can remember. You've got the big X, you've got the difference of squares, and you've basically got GCF. I don't think we do grouping on any of these. So on the top one, you're going to use the big X. I'm just going to put a big X up here, and I'm going to tell you it factors into X minus 3, and that's a K, times K plus 1. The bottom does not factor, so we're going to put it in parentheses. If it doesn't factor, you got to put it together and say, this is the terms that have to stay together. So then I'm going to go to step 3, actually. I'm going to say, what are my excluded values? Excluded values, K minus 3 can't equal 0. Add 3, so K can't be 3. Let's put that down there. Then I'm going to cancel. They both have a K minus 3, so I cancel that factor out of both of them. I end up with K plus 1. There's nothing in the denominator, so that's bada bing, bada boomer. Now, if you do not remember how to factor, you have got to get into the tutor room and get some help, okay? Step 1, factor. Does D minus 3 factor? It does not, so we're going to put it in parentheses. You know how I knew it didn't factor? There's no greatest common factor, and there's no squared. There's no exponent. If there's not an exponent, I can't do the big X or difference of squares. D squared minus 9, however, is the difference of squares, so I'm going to factor it into D plus 3, D minus 3. All right, I'm going to take a little aside. I'm going to go to step 3, which is the excluded values. D plus 3 can't be 0. Subtract 3 from both sides. D can't be 3. D minus 3 can't be 0. Add 3 to both sides. D can't be 3. So you can write negative 3 or 3, or you can put plus or minus 3. Whatever makes you happy. Whatever floats your boat, people. Get that boat afloat. And look, that's a river. Let's draw a boat. Here's our boat. It's floating. Okay, now we're going to cancel like factors. They both have a D minus 3 on the top and the bottom. Now this is different though. Where is the D plus 3 that's left? It's on the bottom, so leave it there. There's nothing left up on the top, but we have to have something up there, so we put a 1. Okay? All right, again, if you can't factor, go get some help. Step 1, up on top, I am going to factor using the GCF. So I'm going to take out a 4, and I get X minus 4. On the bottom, I'm going to use the big X. It comes out to X plus 4, X plus 2. So I'm going to go to my excluded values, skip the canceling first. X plus 4 can't be 0, so X can't be negative 4. X plus 2 can't be 0. Subtract 2, so X can't be negative 2. So your excluded values are negative 4 and negative 2. Remember why? If you put 4 in here, or negative 4, that makes it negative 4 plus 4, which is 0. 0 on the bottom, undefined. If you put negative 2 in here, negative 2 plus 2, that makes it 0. 0 on the bottom, undefined. Pull out the green marker. We can't cancel anything. Can I cancel an X from the top and the bottom? No. Do you know why not? Because they are in parentheses. It is an entire factor. It's a binomial that must be stayed together. Bonds of friendship. So honestly, this does not simplify at all. This is my actual answer. We leave it in factored form. We do not multiply it out. Okay? Okay. Step 1, factor. Up on the top, I'm going to do a big X, and I end up with m minus 4, m plus 1. On the bottom, it's also a trinomial. I'm going to do a big X, and I end up with 2m plus 3 and m plus 1. Again, I'm not going to go over how to factor. You need to go get some help if you're still struggling with factoring. Great review for the final, guys. The final is going to be heavy on factoring. I'm going to take a little skip-a-roo, and I'm going to go to the excluded values. I'm going to take 2m plus 3, say it can't equal 0. Subtract 3 from both sides, it can't be negative 3. Divide everything by 2. M cannot be negative 3/2. Can't be negative 3/2. Also, m plus 1 can't equal 0. Subtract 1. M can't be negative 1. All right, get out that green little marker there, and we're going to cancel like factors. Do you see any factors? Things in parentheses that are the same. M plus 1 on top, m plus 1 on the bottom. So our final answer is m minus 4 over 2m plus 3. Now, oh, look at how well that matches the leaves. Look, it matches. Look at these little guys here. Oh, happy, happy. Okay, it doesn't have to be in parentheses at this point, but if you want to leave it in parentheses to remind yourself you can't do any more canceling, that's not a bad idea. Because you know what people do? They cancel those m's. Don't do it. Okay. Divide. Oh, look at those tulips, so pretty. All right, divide. Now, this is kind of weird, but remember, divide means in olden days, you put like this number inside your dividend, just for funsies. We'll go through these words. Dividend, inside, outside is your divisor. You're going to need to know that in Algebra 2. Be the smart one. We don't do that here. What a fraction is a division problem. You put the numerator, which is the dividend, up on top. And the divisor, the thing you're dividing by, goes on the bottom. So when it says divide, it just means write it as a fraction. We're going to use the big X on top, and we're going to get m minus 3 times m minus 1. On the bottom, it does not factor, but it's a binomial, so we're going to put it in parentheses so that we remember it has to stay together. Okay, skip down to your excluded values. Take your denominator, set it not equal to 0. Now, I've been skipping that little plus 1 step. Probably shouldn't do that. So m cannot equal 1 because 1 minus 1 is 0. That puts a 0 on the bottom, undefined. Okay, then do we have a factor on top and bottom that can be canceled? Yep, the entire m minus 1 can cancel. So my final answer is just m minus 3. Now there's nothing on the bottom, so if I wanted to put it over 1, I could, but we're kind of lazy. We don't do that. We're kind of like this little tulip. We're falling over. No, I have fallen and I can't get up. Okay, Daisy, Daisy, give me my... Okay, on the top, I'm going to factor using a GCF. I'm going to pull out a 4. When I do that, I get n minus 7. On the bottom, I'm going to factor using difference of squares. It's going to be n plus 7, n minus 7. Once it's factored, I'm going to skip to the excluded values. You set the denominator not equal to 0. Subtract 7, n can't be negative 7. And you set n minus 7 not equal to 0. Add 7 to both sides. N can't be 7. Just a little aside note. If you set n squared minus 49 before you factored it out, not equal to 0, you would say n squared cannot equal 49. You would take the square root of both sides, remember the plus or minus, and oh, looky, looky, you get the same thing. Just by putting it together. Unit 7. Memories of the Unit 7. Okay. Oh my goodness, that just choked me up. Here we go. We've got an n minus 7 factor on top and n minus 7 factor on the bottom. We're going to cancel them. Our final answer is going to be 4 over n plus 7. Okay, we are zipping. These are so short compared to the last one. Daffodils, those are my favorite. I absolutely love it. Now, here's what's really important here. You need to read the directions. Does it say to simplify it? No. All it says is state the excluded value, which means we don't care about the numerator. So you can do this 2 ways. Okay, here's way 1. You can factor it, because that's what we tend to do in this thing. So it's x minus, that's a p, come on Evans, p minus 9 times p minus 4 is what the denominator is. So for my excluded values, p minus 9 can't be 0, so p can't be 9, and p minus 4 can't be 0, so p can't be 4. Or the other method is just set the denominator not equal to 0 and then solve it. Well, guess what we have to do to solve this? We actually have to factor it, and then we get to the exact same thing. But I just want you to see how what we did last time is the same thing we're doing this time. Change the slide. Boom! Okay, we are again stating just the excluded values. We are not simplifying it. So we're only going to look at the a squared plus 8a plus 15. So we're going to factor that using the big X. It comes out to a plus 5 times a plus 3. It's my denominator, so neither one of these factors can equal 0. So I set them not equal to 0, and I find out that a can't be -5 and it can't be -3. Now, if I'm going too fast, if I switch the slide before you're done, oh, I like that. If I switch the slide before you're done, you're just going to pause. It's an amazing concept. Again, we're just stating the excluded values, so we don't care about the numerator. I'm going to factor the denominator using the difference of squares. It's x plus 4, x minus 4. And when I find the excluded values, I say x plus 4 can't equal 0. So x can't equal -4. And I find x minus 4 can't equal 0. So x can't equal 4. -4 and 4. This is one again where you could have done x squared minus 16 can't equal 0. X squared can't equal 16. X can't equal positive and negative square root of 16, which is 4 and -4. Next slide! Oh, I almost missed it. It's down here. State the excluded values. Okay, I would be doing pink, but I don't have pink. So excluded values only care about the denominator. When I factor that, it's m minus 5 times m minus 1. For the excluded values, m minus 5 can't equal 0. Add 5 to both sides. M can't be 5. M minus 1 can't equal 0. Add 1 to both sides. M can't be 1. Last slide is again just stating the excluded values. Ooh, we should have really done this one. This one's got a little hitch in its get along, but we're not doing it. All right, so we're just looking at the bottom. We're going to factor this using a GCF. Pull out a 5, we get x minus 6. So for the excluded values, 5 can't equal 0. Well, duh, that doesn't tell us anything. X minus 6 can't equal 0. Add 6, x can't be 6. Bada bing, bada boom, 13 minutes, booyah! Bring all your little filled out notes to class. Get those points. Life is good. Hey, see you later, alligator.